Homework 15 is solving inequalities. These first four problems are all the exact same. We just change our inequalities, okay, which is going to change our answer for interval notation. All right, so we first have to solve for x, get our zeros. So I'm going to factor, it's going to factor as x minus 4, x plus 2. Greater than or equal to 0. Okay, so our 0 here is going to be 4, and our 0 here is going to be negative 2. All right, so we're going to put this on a number line. I'm going to make them a little bit longer than I usually do. Negative 2 goes here. Negative 2 goes on the left, 4 goes on the right. Okay, now, this is going to be intervals. All right, we've got to find our interval notation for this solution here. So what we're going to do is we're going to pick test points. We're going to pick some number that's between negative infinity and negative 2. Let's just go with negative 5. Okay, it doesn't matter what number. Let's make x equal to negative 5. Then I'm going to pick a number between these two. It doesn't matter what number you're going to pick, but I like to use 0 because it seems to make the problem easier. Okay, and then right here, pick a number to the right between 4 and infinity. So to the right of the 4, I'm just going to pick, let's say 5. Okay, these don't have to be the same. It's just a number I picked. So what we're going to do is we're going to take these values and plug it in here. Now I'll show my work for the first few. You're going to take your x out and you're going to replace it with the negative 5. So you're going to have negative 5 squared minus 2 times negative 5 minus 8. Okay, so I'm just going to put it in there. Now we're going to compare it to this. It's got to be greater than or equal to 0. If it is, then it's going to be, then that's part of our solution. Okay, so, and you can let your calculator do the work. It doesn't really matter at this point. It's probably going to be easier for you because we're going to have to place these numbers in. Okay, so, or you can just, plug it in however you want to, but you're going to, I'm going to say negative 5 store x. Then you're going to get, I'm going to type that in, x squared minus 2x minus 8. And it gives us 27 because this is 25. Positive 10 is 35. Minus that 8 is going to give us 27. And we're going to compare it to the 0. So we get 27 on the left side. Is that 27 greater than or equal to 0? Yes, that is a true statement. Okay, that's a true statement. So I'm just going to mark that with a smiley face. Why? I don't know. You can just put true or false. You can put check there. That means, by the way, because this is equal, we are going to make them solid circles. If I was to plug 2, negative 2, it's kind of, let me move that negative 2 up. Okay. If I was to plug negative 2 into this function, it would give me 0, and 0 is greater than or equal to 0. Same thing with 4. It would make this a true statement. This would give me 0 if I plug in 4, so it is equal to 0. So that's why they're solid circles. So because this worked, we have a smiley face, that means all of these numbers are going to work. Okay, so this part is that negative infinity to negative 5 solid circle, so it's a bracket. Okay, now we're going to take our equation, our function, and wherever we see an x, we're going to plug in 0. So I'm going to take out my x. So it'd be 0 squared minus 2 times 0 minus 8. Well, that gives us 0, that gives us 0. You get negative 8 is greater than 0. That is not true. So I'm going to just put a frowny face just because it doesn't work. We're trying to find our solutions. And again, You can do that on your calculator. I personally just put -8, but even if you had to use your calculator, store 0 under x, bring it back up, and you get -8, okay? So now we're going to start with 4 and see if this works. Again, this could be 5, this could be 6, 7, 8, just some number that's larger than 4. I just happened to pick 5. There's no rhyme or reason, I just needed a number. So you're going to say 5 squared minus 2 times my 5 minus 8, and hopefully it's greater than or equal to 0. Okay, so 5 store x, bring it back up, bring it back up, and you're going to get 7 because this is 25 minus 10, that gives us 15, minus 8 gives us 7. So we get 7 on the left is greater than or equal to 0. That is a true statement. So I'm going to put a smiley face. So it works. So it's all of these numbers. Well, if we put that in interval notation, we're going to have bracket, put a union, bracket 4 to infinity. Okay? And that's our answer, because all our answers are going to be in interval notation. Now, all these next 3 are the exact same problem, except for we change our inequality from a greater than to just, greater than or equal to just a greater than. So again, when we go to put this, we don't have to do all this same work up here. We don't have to do that. The only difference, the thing that's going to happen, these are still our zeros, okay? Because again, it's the same function. Now they are open circle at those numbers, okay? So again, I'm using the exact same thing. I'm not going to change these numbers, but I could put x is equal to, let's say, -3, -4, -5, whatever. You just need a number between -infinity and -2. Because I've already done my work up here, I'm not going to do it again. So what I do is I take -5, plug it into here, like I did up here. I am going to get 27. But now, is 27 greater than 0? Yeah, okay. It just changed. It doesn't have the equal sign, okay? So still smiley face, okay? Then, because I've already used 0, I'm going to still say 0. And then same thing with the 5. So when I plug these in, when I plug in 0, I'm going to get -8. Is -8 greater than 0? No. So that's going to be a frowny face because it doesn't work. You don't have to use a smiley face in the frowny faces. You don't have to. And then when I take 5, I plug it in here just like I did up here. I'm going to end up with 7. Is 7 greater than 0? Yes. So again, smiley face. So it's going to be all of these numbers, okay? So now our interval notation is going to change just a little bit. It's -infinity to -2, but instead of a bracket, we're going to have parentheses. Same thing over here, parentheses, because it's an open circle. It does not include that to infinity. It includes anything past that's greater than 4, just not 4, because if I plug in 4 here, it's going to give me 0, and 0 is not greater than or equal to 0. I'm sorry, it's not greater than 0. All right, same thing. I'm going to use the exact same numbers. I find my 0, which is -2. I find 4, my 0, which is 4. Again, closed circle because it's equal or filled in. I'm still going to use the same values because I don't have to do the work, okay? So if I took -5 and I plugged it into this equation, I'm going to get 27. Is 27 less than or equal to 0? No, that is a false statement. So I'm just going to use a frowny face. Again, I am going to use x equals 0 here, and I'm going to use x equals 5 because I've already done all the work up top. Okay, when I take 0 and I plug it in here just like I did up here, I got -8. Is -8 less than or equal to 0? Yeah, it is. So this is part of the solution. If I'd have picked -1, it would have worked. If I'd have picked 1, 2, 3, it would have worked. Any number between -2 and 4 would have worked. And so now when I take -5, because I'm going to check them all. Because every once in a while there'll be a tricky one. If I take 5 and plug it in here, I'm going to get 7. Is 7 greater than, I'm sorry, not greater than, less than, sorry, I'm looking at my work up there. Is 7 less than or equal to 0? No, it's not. So that's going to be a frowny face. Where's the smiley face? Okay, smiley face, it's a bad frowny face. Whoops, and I don't know why I did that. Okay, I'm sorry, boxing in my answer that I don't have. All right, so solid circle, so I'm going to have bracket -2 to 4 bracket. So that's my answer there. And then the last one that we're going to do with this particular function, then we're going to change, okay? They changed from a less than or equal to just a less than. So again, it's going to be the exact same thing as up here, except for they're going to be open circles. So if I take, I'm going to use x equals -5, still x equals 0, and x is equal to 5, okay? So again, when I plug in -5 into here, I'm going to get 27. Is 27 less than 0? No. Am I going to, when I plug in 0, okay, when I plug in 0 in here, I'm going to get -8. Is -8 less than 0? Yes. So that one is a smiley face, and that's where this goes. Okay. And then over here, if I plug in 5, I'm going to get 7. Is 7 less than 0? No, it's not. So again, frowny face. So now our solution is parentheses -2 to 4 parentheses. I don't know why I did that in purple, but that's okay. Because it doesn't include the 2 and the 4, the -2 and 4, because that would give us 0. 0 is not less than 0. Okay, we're finally going to change different problem, okay? Now, on this problem, you've got to get it set equal to 0. So I'm going to have -10 is greater than or equal to, I'm going to distribute this. I get 3x, and I get -x squared. All right, so I got to get everything over to one side. I want my x squares to be positive. So I'm going to add x squared to both sides, and it becomes positive. That goes away. I'm also going to take this 3x to the other side because I need one side to equal 0. That side now, my right side, gives me 0. So I got to subtract it over here. So now I have x squared minus 3x is greater than or equal to 0. Okay, oops, hold on. Forgot my -10. X squared minus 3x minus 10, little detail there, is greater than or equal to 0. Okay, now it's going to factor. X minus 5, x plus 2. So my zeros or critical points, whatever you want to call them, this is 5, and here it's -2. All right, put them on a number line. Put the smaller one on the left, that would be -2. Larger one on the right, which is 5. You can put all your other numbers, I'm just lazy. All right, because it's got to equal solid circles. Okay, and the reason it's solid is because when I plug in, these are our zeros. If I plug this into this, well, in here, or down here, it doesn't really matter. If I plug it in here, I'm going to get negative 10. Okay, if I plug in 5, I'm going to get negative 10, and both negative 10 is greater than or equal to, it's equal to that negative 10. If I plug it here, it's going to give me 0. So either way. Okay, so I'm going to pick a number to the left of negative 2. I'll just pick negative 3. Okay, so I'm going to put x equals negative 3. I'm going to pick a number between here. Anytime I can use 0, I'm going to use 0. Because I don't have to do any work. I know it's going to be my constant, a negative 10. And here, oh, let's pick 8. Why? It's larger than 5. You can pick anything you want. Okay. So I'm going to use this because I like to compare mine to 0. And to me, this is easy when you go plug this in. So you just got to make sure your math's right. Okay, so I'm going to take out my x and I'm going to put in a negative 3. So I'm going to do it down here. I'm going to have negative 3 squared minus 3 times negative 3 minus 10. It'll be a smiley face if that gives me something greater than 0. Okay, so wherever I saw an x, I put my negative 3. So let your calculator do the work. Even though I don't need it, a lot of you would probably do better using your calculator. And if you use your store button, you don't have to worry about that, because this needs to be in parentheses if you're going to square it, because that gives us a positive 9. If you don't put it in parentheses in your calculator, it is going to give you a negative 9. So that's why I like to use the store button, because I don't have to worry about it. So x squared minus 3x minus 10. And that gives me 8. So is 8 greater than or equal to 0? Yes, it is. So we're going to do a smiley face. Okay. So that means all of these work. Let's plug in 0. I'm going to stop changing my pens. 0 squared minus 3 times 0 minus 10. Again, you should not have to do all that. You should know that it's going to give you a constant. That gives us negative 10. But if you don't, use your calculator. Okay. Is negative 10 greater than or equal to 0? No. So that will be a frowny face. Okay. Now again, you can do it here, but I like using 0 because really all I need to know is that this is positive or negative. If it gives me a positive number, it's going to be true. If it's going to give me a negative number, it's going to be false. So, but we're using our calculator, so it just makes everything easier. And you don't even have, if you didn't use your calculator, it'd be one thing. Okay, so wherever I see an x, I am going to put an 8. So I'm going to say 8 store x, bring it back up, and I get 30. Is 30 greater than or equal to 0? And yes, it is. Okay, so it's going to be all these. Remember, it doesn't have the directions on here, but the solution to this is going to be an interval notation, because that's when you use it, is when you have an inequality. The interval notation, okay, for right here, I'm just going to put it down here because I kind of got low on my paper. It is negative infinity to negative 3 bracket, because it's a, let's try a negative 2, not negative 3. Okay, bracket because it's a solid circle, and then union 5 to infinity. So that's the answer. Okay, next page. Now, you should be happy when you see it like this. It is already in factored form, so you don't need to do it. Okay, you don't have to factor it. Anything with an x you set equal to 0, including this. Okay, here it's got to be 0, because you say x equals 0. Here, my x is going to be 3. If you set x minus 3 equal to 0, you get 3, which we've already covered all this. This is going to give us 2, and here it's going to give us -1. Those are our zeros, okay? Because this is a less than, then that means they're going to be open circles. Now be careful here, we've got 4 things. We have put the lowest number on the left, which is -1. That's the smallest number, not or lowest. Then 0. Then 2. Then 3. So I got to pick something. Some number to the left of -1. Let's make it -4. Some number between -1 and 0, I'm just going to make it a -1/2, or -0.5 is perfectly fine. Something between 0 and 2, I'm going to choose 1, because again, I'm going to choose whole numbers if I can. Here I can't, so I'm going to take 2.5 or 2.5. I'm just so used to using fractions. And then here, let's just use 4, okay, because it's bigger than 3. Now, what am I going to do with that? I'm going to take my calculator. I am going to take -4 and plug it in here. -4 store x. Now I'm going to plug this in just like I see it. X times the group of x minus 3 times x minus 2 times x plus 1. Okay, let's make sure I typed it in right because I don't have anybody here to tell me. And I got 504. I get 504. I don't know why I grabbed my blue pen. Is that less than 0? No. Frowny face. It's a really bad frowny face. Now I'm going to say, it doesn't matter if you say -1/2, and I'm really lazy about I just do my fractions like that. And I store it under x, it's going to change it to a -0.5. So that'd be perfectly fine. I could have used 0.75, just anything between 0. Could have been 0.2, anything between 0 and -1. All right, now I'm going to bring it back up. And I get a negative number. Is this negative number less than 0? Yes, all negative numbers are less than 0, but I'm just going to say -2.2. I'm just going to round it because it really doesn't matter. I just need to know that it's negative because negative numbers, I'm just going to put that. I'm going to get some negative number, whatever number you use, okay, is less than 0. So this is going to be a smiley face. I'm not looking for this number. I'm looking, by the way, these are all open circles. I'm looking for this interval between here and here. That interval is going to be, it's an open circle. So that interval is from -1 to 0. That's what I'm looking for. I'm really not looking for what this number is. If I'd have chosen, let's say, a -0.1, because that is between 0 and that, and I store that under x, and I bring that other one back up, I still get a negative number. So, and all negative numbers are less than 0. All right, so now I'm going to take 1, store it under x, bring it back up, and I get a +4. So I have positive, positive, is that less than 0? No. Now again, you can put 4 if you want, okay, but positive number is not less than 0. So it's a frowny face. Forgot to put my open circles at 2 and 3. So now I'm going to take 2.5 or 2.5. I'm going to use 2.5. Store x. And then I'm going to bring it back up. And I get another negative number. Okay. So all negatives are less than 0. So that's going to be a smiley face. So it's all these numbers right here. Again, you can put the number if you want. It doesn't really matter. I don't care. And now I'm going to try 4 store x, and I get 40. Positive 40, or you can do this, 40 is less than 0, okay? And that's not true, okay? So we have this interval. Anything on this interval in between -1 and 0 is going to make this a true statement. Anything between 2 and 3, not 2 and not 3, but anything larger than 2 but smaller than 3 or less than 3 is going to work. Notice I use parentheses because they're open circles. Okay, now this one right here, I know it's squared. Okay, I realize that. So this just means I have 2 of these. That's all that means. Okay, that's it. And then, because I could have written it like this, right? It's the same exact thing. Here I'd get a positive 2. Here I get a positive 2. I only need one of them. And here it's going to give me a -3. Those are my zeros. So 2 and -3. So right here, I'm going to have an open circle. And I'm going to have an open, ooh. Let's try switching these around. -3 needs to go on the left and 2 needs to go on the right. I was thinking of positive. I don't know what I was thinking, obviously. All right, let's pick our test points. I'm going to pick -4. Again, I'm going to pick 0. You can pick 1. You can pick whatever you want. And I'm going to pick, let's say, I don't know, 6. Okay, those are my test points. So I've got -4 store x. Okay, and now I'm going to plug this in. X minus 2 squared times x plus 3. And that gives me -36. Is -36 greater than 0? No. Frowny face. Right here, 0, store x. Bring it back up. And I get 12. Is 12 greater than 0? Yes, that's a true statement. And you could just do positive, okay? So I know it all works here. And now let's try the 6. 6 store x. Bring it back up. We get 144. That's why you always got to check. You have to check. And it has to do with this multiplicity, okay? Because, yes, 144 is also. See, I bet you guys thought it was going to go no, yes, no, because that's what's happened on all the other ones. They've alternated. But it doesn't always, it's not always true. So now we have to write this in interval notation, okay? So let's ignore that part right there. So I'm going to start open circle. I'm going to start at -3. I'm going to go to 2, and I have to stop it because it's an open circle. It's not, there's a hole there. So that takes care of those 2. Now I've got to take care of the right side of 2. So parentheses 2 to infinity. Okay. All right. Okay, let's look at this one. This one looks similar except for it's the exact same problem as up here. So I'm going to use the same numbers, but now we're going to have solid circles. Okay, that's going to change our answer. See if I can do my number line right this time anyway. All right, so again, I'm going to pick -4, 0 and 6 because we've already done the work up here. Except for when I do this, we get negative 36. Whoops. Is it greater than or equal to 0? No. Frowny face. By the way, negative infinity here, infinity here. The other thing is because it's equal, solid and solid. Okay? So when I plug in 0, we're going to get 12. Is 12 greater than or equal to 0? Yes, it is. Smiley face, so it's all these. Okay. And then when I pick 6, 6 gives us 144. Is 144 greater than or equal to 0? And yes, it is. Okay. Now, we're going to start at negative 3. It's a solid circle. So we're going to use a bracket. Okay. You do not see any holes. There are no holes to the right of negative 3. So you're going to write this as infinity. We did not do that up here, and that's because there was a hole there. There's no hole right here. There's more points on this line, we just don't write them. Like even here, there's a point right there. You just can't see it because the line, I could make this a really thick line. I could make it a really thick line and make that point disappear. Okay? Well, not really because my pen, but see what I'm talking about? I can't, even if I made this thick, I'm still going to have a hole there no matter how thick these lines are. So that's why you're going to write it like this. Do not, this is our answer, okay? Some of you will write it like this. That is not the, yes, it kind of means the same thing, but you don't need to write this because that means 2 is included. Well, 2 is included here. So don't write it like that. Write it like that. Okay?